In part 2, we start with a very sad story. Romeo had decided to leave Juliet, and they both decided to go off in separate directions. As you know, parting is such sweet sorrow. Romeo rides his horse at 20 miles per hour, while Juliet rides her horse at 15 miles per hour. And after 3 hours, we know they're 80 miles apart. Find the angle between their paths. So we first thought, well, of course they had a bad breakup. When they were breaking up, they were together. So here's where the breakup occurred. We'll call it this little point down here. Now, Romeo goes off in one direction, and after 3 hours, he winds up at this point right here. We'll call that point Romeo. Juliet goes in another direction over here, and after 3 hours, she winds up over here. Now, after 3 hours, we're told the distance between them is 80 miles. Now, what we're asked to find is this angle between their paths. So first of all, let's name our triangle. We'll call this A, B, C. Doesn't matter the order. I just call them A, B, C just because that's where I saw it. So we're trying to find angle C right here. So we don't have enough information because right now we only have one side. But with the information they gave me, I can actually find little b. Because remember, they're telling me Romeo's traveling at 20 miles per hour. And he travels for 3 hours. So we know that b is 60. And the same thing for Juliet. Juliet is traveling at 15 miles per hour. That's going to give us a. She travels for 3 hours. So giving us a is 45 miles. So in that time, Romeo traveled 60 while Juliet traveled 45. And now we can actually draw a triangle again, make it look a little bit nicer. A, B, C. This is 80, 60, and 45. And if you notice, this is side, side, side. Therefore, this is our law of cosines. And since I'm looking for the angle, angle C, I'm going to use my C one. And you don't have to memorize it. It's basically, well, you have to memorize it, but it's basically Pythagorean theorem. It's going to be C squared equals the other two sides, A squared plus B squared minus twice AB times the cosine of the angle C. And that's our formula that we're going to use. So, plugging it in, C squared, the opposite side is 80 squared. A is 45, so we have 45 squared. B becomes 60 squared minus 2A, which is 45, B, which is 60. And we get the cosine of C. Now, typing all this in the calculator and simplifying it, bringing over the 45 squared and the 60 squared and 80 squared. So I'm going to just take 80 squared minus 45 squared minus 60 squared, and that's going to give me 775. Typing all of this in the calculator, we get negative 2 times 45 times 60, 5,400 cosine of C. So, dividing the cosine of the angle C, we get 775 divided by negative 5,400. We get negative 0.1435. Always go about 4 decimal places with trigs. C is about, then we take the second cosine. Right, we get the second cosine. Second cosine, negative 0.1435. And it gives me about 98.250 degrees. So the angle between them is about 98 degrees. All right, now, for question number 2, we have a surveyor, and we're given the length of a triangular field. And so I'm going to draw that triangular field. One side is 25. One side is 38, the other side is 45. It doesn't matter the order, just draw your triangle. We have our triangle. We want to find the measure of the smallest angle. So we're going to have to review a little bit of geometry. And from geometry, we learned that the smallest angle is opposite the smallest side. That's from geometry. So our smallest angle is going to be C. So we're asked to find angle C again. Right, like this. Now, look at what we're given. We're given side, side, side. So we're given side, side, side. Therefore, this is our law of cosines. It's our law of cosines. So we're just going to set it up. C squared equals A squared plus B squared. Just memorize if I'm looking for a side C, or anything we do with C, it's C squared, A squared plus B squared, minus twice this A and the B, the same two, cosine C. Like if I was looking for angle A, it'd be A squared equals B squared plus C squared minus 2BC cosine of A. So, but we're not looking for that one. So C squared, we get 25 squared equals A squared, which is 45 squared, plus B squared, 38 squared minus 2, 45 times 38, cosine of C. And solving this one, what I would like you guys to do is to finish this one and bring it in class tomorrow. It's just like question number 3. Finish, and we'll go over in class tomorrow. Now, the other thing we're asked to find here is the area. And since we're given all 3 sides, we're going to use Heron's formula. So, also do me a favor, finish up this one, find angle C, and find the area using Heron's formula. Okay? And we'll go over those 2 tomorrow in class. I want to spend time with number 3 here. The mighty Chewbacca is asked to find the height of a nearby building from where he initially stands. So here's Chewbacca. So let's find out. He initially stands. He's trying to find the height of some building. From where he initially stands, he measures the angle of elevation, we'll draw the ground, to be 36 degrees. Then he moves closer to the building by 50 feet. And he also measures the angle again. But this time the angle becomes 58 degrees. Now, just like question number 2, this is going to be a little bit harder to solve. Okay, but one thing I want to point out to you, take a look. This is kind of a real-world problem. How can you find out how tall buildings are? This is how they find out. This is how they used to find out how tall mountains were. So, they didn't have rulers. They would just use trig. So what we're going to do is we need to find this height. And I'll draw that in red. We need to find the height of this triangle, right? The height of this part right here. Now, if you notice, I do have a right triangle. And I have an angle in that right triangle. So if I could find the side, this side right here, I would be able to find the height using my right triangle trigonometry. So let's go ahead and label our triangle, AB, our known triangle, C. We're trying to find, right now, A. So we have to find little a. So if I draw it now, I can use the fact that this is a line to get this one right here. So this is just going to be 180 minus 58, and that becomes 180 minus 58, which is 122 degrees right here. Now if you notice, I have angle, angle, side. So I now need to know this triangle angle right up in here. And I can use, if I use this triangle, find this angle right here, I can use a 180 again. It's going to be 180 minus 122 minus 36, which gives us 22 degrees. And now if I draw this out again, just so we can kind of see a little bit better, A, B, C, 36, 122, 22, and that's 50. I can now find A, because now I have angle, angle, side. I can use my law of sines. So we are going to take the sine I'm looking for A of 36 over A equal to the sine of 122 over, that's not 122, sorry, just the 22 degree one, this one, over 50. And cross multiplying, we get A sine of 22 equals, and if I multiply across here, we get 50 times the sine of 36, which is 29.389. Sorry. So A is about, so we take that 29.389, divide that by the sine of 22, we get about 78.453 feet. So A here becomes 78.453 feet. So we go over to here. We know this side right now is 78.453 feet. Draw out your triangle, that right triangle part. Now just redraw it out. It's always good to redraw it out. This is 58 degrees. That's H. We know that this is 78.453. And now I can just use right triangle to find H. These take a lot of practice to do, so you want to try these again tonight. So we're going to use sine of 58 equals H over 78.453 degrees. So just cross multiply here. We get the sine, there it is, we get the sine of 58 times 78.453, and we get about 66.532 feet. So the height of the building is roughly 66 feet tall. Now, what I would do for tonight is definitely rework problems number 2 and number 5, and we will go over these again tomorrow. We'll get some more practice on these. Thank you. Bye-bye.